So up next, let's talk about the Pandas library. This is a very handy library for slicing and dicing data before you actually try to process it, and we'll make extensive use of it in this course. If you don't have Jupyter Notebook already open, again, just go to your Anaconda prompt, which you can find in your Start menu, and cd into wherever you installed the course materials, and then type in Jupyter Notebook, again with a Y, it's spelled funny, and up should come in your browser, the directory. Go into section 3, and we're going to click on Pandas tutorial.ipynb. So this little notebook gives you an introduction to the Pandas library, so you'll be familiar with it when we start to use it later in the course. Definitely not a comprehensive introduction to Pandas, but just enough for you to get started. So basically, there are three main libraries in Anaconda that kind of play with each other in the worlds of machine learning. One is Pandas, which we're going to talk about now, and really it's a way for making tabular data easier to handle and process. So it kind of treats multi-dimensional arrays of data as sort of like a little database you can mess around with in easy ways. It introduces a couple of concepts. One is the data frame, which you can think of as kind of like a little very low-tech database to some extent. You know, it's basically a 2D array, generally speaking, that has rows of information, and each row contains some set number of features associated with each row. It'll make more sense when we look at an example. It also has series, which are basically one-dimensional arrays of information as well. Another package we deal with quite a bit in the world of data science and machine learning is NumPy. And in NumPy, we have something called an array, which is basically a multi-dimensional array of information. Very similar to a Pandas data frame, and it's easy to switch back and forth between the two, actually. So you can create a Pandas data frame from a NumPy array, and you can create a NumPy array from a Pandas data frame. And often you do need to sort of switch back and forth between these two worlds. Specifically, we're talking about NumPy arrays because they tend to be the inputs into scikit-learn, which is the machine learning library that we use pretty often within the world of Anaconda. Generally, it takes NumPy arrays as its input. So a lot of times you'll end up loading and manipulating and cleaning your data using Pandas because that's the easiest place to do it. Convert that Pandas data frame into a NumPy array, and then pass that NumPy array into scikit-learn. And in a lot of cases, you can actually do that conversion automatically. You don't always have to explicitly convert your Pandas data frame into a NumPy array for scikit-learn to use it. Often you can pass that in directly as a Pandas data frame, and that conversion will happen implicitly under the hood for you without really thinking about it. Anyway, let's take a look at a simple example and use Pandas to mess around with some data that we've created here. So we're going to start off by importing the packages we're going to use. Before that, though, we have this little directive here to the notebook itself. That %, matplotlib inline just tells the Jupyter Notebook environment that we want to plot any graphs as part of this notebook itself. So if I try to chart anything, I don't want a separate window to show up. I just want it to be part of the notebook itself in my browser. That's all that matplotlib inline means. We're then going to import the NumPy package as np, so we can refer to it as np. And we'll import pandas as PD, so we can refer to the pandas library as PD for short. Now that we've done that, we can use pandas to load up a CSV file, comma-separated values file, that exists out on my website. So it doesn't have to just load it from your hard drive or from your cluster. You can actually head out and load stuff over URLs through HTTP as well. So we're going to create a pandas data frame called df, and we'll assign that to pd.readcsv with a URL to carvideos.csv. And all this is a very fabricated, fake, comma-separated values data file that I made that just has fictitious cars along with information about videos captured from those cars. So if we do df.head, that lets us preview the start of this data frame. So head will just automatically give me the first 5 rows in that data frame. Go ahead and run that. And we can see that the data looks like this for each individual row. We have a video ID associated with it. We have the vehicle that took that video, the weather conditions at the time the video was taken, and a timestamp for that video as well. So you can imagine this being sort of an index into video files that we want to mess around with for actually training a computer vision system or a machine learning system for a self-driving car, for example. Now, head is just a handy way to sort of spot check it and make sure you understand the structure of the data you've imported, and also make sure that all the headings are right and the columns are where you expect them to be and stuff like that. You can also pass in a parameter to head to say I want to look at a specific number of rows. So head 10 would give me back the first 10 rows in that data frame. And there they are. You can also look at the end of the data frame using the tail command as well. So tail 4 would give me the last 4 rows in my data frame. which are rows 8, 9, 10, and 11, because I only have 12 rows in this data frame. Often we talk about the shape of a data frame as well. That's just the dimensions of the data frame. So in this particular CSV file, we only have 12 rows, 12 different cars, and each one of those rows has 4 features or columns associated with it. So the shape of that data frame is 12-4, meaning we have 12 values in the first X dimension. We have 12 different rows or 12 different cars in our data frame, and each one of those rows contains 4 values that correspond to the video ID, the vehicle, the conditions, and the time associated with that row. So basically, 12-4 means we have 12 rows with 4 columns per row. We can also call size on the data frame, and that gives us back the total number of elements in that data frame. So that's going to be the rows times the columns. 12 times 4 is 48. So we have 48 distinct cells within our data frame here that contains information about videos that came from cars. If you call the len operator on your data frame, that gives you back the number of rows in the data frame, so that comes back with 12. There are 12 rows in our data frame, so the length of the data frame is 12. We can also extract the column names. In this example, the data frame automatically extracted the column names from the first row of the CSV file, and we can just print that out to make sure that it has the right names. Sure enough, the columns include video ID, vehicle, conditions, and time, so we can now refer to those columns by their name if we want to. Let's take a look at that in action. So for example, we can extract the time column by itself and say df bracket time. What this does is create a new data frame that only contains the time column. So it looks up that time column based on its name and just extracts that for you. And there we have it, a single data frame with just that time column and nothing else. Now technically, because we only asked for a single column, we're not getting back a data frame, we're getting back a series, okay? Because it's only a one-dimensional data. Data frames generally have more than one column to them. But since we only extracted a single column from our data frame, time, what we're getting back is actually a series as opposed to a data frame. So it's a slightly different kind of object that you sometimes have to treat a little bit separately. You can also extract a range of rows from that column as well. So I could say df time, and that gives me back a time series. And then I can use :5. That's the same syntax we would use with lists in Python to extract the first 5 elements from a list. That can also be used on Pandas series as well. So what this does is give us back the first 5 rows with just the time information from that data frame. You can also extract a single value just like you would with a list from a series. So if I want the element number 5, which is actually the 6th element because we keep starting to count at 0 here, from the series that came out of extracting the time column from our data frame, we end up with 503, which is the time associated with our 6th row in our database here. So you can see there, counting up from 0, the 6th row is actually element number 5, which is 503, which we got back here. You can also pass in more than one column, and this will give us back a data frame instead of a series, because now we're asking for more than one column. All you have to do is pass in a list of the column names you want to extract. So we're saying df bracket to say that we want to reference that data frame and take something out of it. And then we pass in another list here of the actual columns we want to suck out of it. So this is saying extract out of the data frame df the vehicle and time columns and give that back to me as a new data frame. Sure enough, it works. We now have a new data frame that just contains nothing but the vehicle and time columns. And this can come in handy because a lot of times you'll have raw data that has a lot more information than you need. And you want to distill that down to just the information that you want to process. So that's the syntax for just extracting the columns that you care about. And just like you could extract specific ranges from a series, you can do that with a data frame as well. So I could extract the vehicle and time columns from df and just take the first 5 rows out of that by saying :5 at the end of that, just like we're doing here. And you can see that not only have we extracted the vehicle and time columns, we've only extracted the first 5 rows of those 2 columns. Sorting is pretty straightforward. You can just say sort_values to actually sort a data frame by a given column. So we're going to say we want to take the vehicle column here and sort based on the values in that column. That gives us back a new data frame sorted by the vehicle. So you can see here we have all the Model 3s together, all the Model S's together, and all the Model X's together, because we sorted by the vehicle column. Very straightforward. Another cool thing is value counts. So this actually gives you back a series that maps each individual distinct value in a column by the number of times that value occurs. Okay, so What we're saying here is we want to get back a series called vehicle counts that takes our data frame, extracts the vehicle column from it, and counts up how many times each value occurs. Then we'll print that out. And you can see here what we're getting back is that our data frame contains 6 instances of the vehicle Model 3, 4 Model X's, and 2 Model S's. So that's what value counts does. It gives us sort of the information we need for, say, a histogram of plotting how often unique values occur. And since I mentioned a histogram, we may as well mention too that it's pretty easy to actually plot things from pandas as well. Since we did import matplotlib, we can just call .plot on the resulting series, say that we want a bar chart, and it will go off and do the right thing. Now remember too, we said matplotlib inline, so it will plot this as part of our actual notebook here. And sure enough, it worked. You can see here this little histogram that shows that we have 6 Model 3s, 4 Model X's, and 2 Model S's in nice graphical form. So that's a little bit of an introduction to what pandas can do for you. It's obviously very powerful, and there's a lot more it can do too, but very useful tool for actually extracting the data that you care about and preparing it before you actually try to feed it into some sort of machine learning algorithm. As a little bit of a challenge for you, here's a little exercise. Should be pretty straightforward. Try extracting just rows 5 through 10 of the data frame, DF. Extract only the vehicle and conditions columns. Assign that to a new data frame. Okay, so we're going to say, df2 equals df whatever, right, to extract what I said. Plenty of examples like that above here to look at. And then I want you to create a histogram plotting the distribution of the conditions in the subset of that data. So take that resulting data frame and make a histogram just like this one, but for the conditions as opposed to the actual vehicles. Okay, just based on that data frame that we extracted from the original one. So go ahead and give that a shot if you want a little bit of hands-on practice with pandas. But otherwise, you've seen how it works at a high level, so hopefully pandas won't look foreign to you as we start to use it further on in this course.